So we've spent so far time where they gave us a 0 and we used our synthetic substitution, like that synthetic division process, to help us find like a depressed polynomial that we could then factor and find the other zeros. And then we spent some time practicing just solving them by factoring. So like that's what we were just going over, pulling out anything that they have in common, trying to factor it using our factor rules that we talked about back in chapter 2. Now, not all polynomials are factorable. So far we've just been looking at the ones where they were, like especially yesterday when we were going over some extra examples there. But there's some out there that you can't factor. And so we did see a little bit of that when we were doing the notes from the first day, where we had to use like synthetic substitution, and then we actually ended up using like the quadratic formula instead of factoring because we couldn't factor it. So we have something called the rational root theorem, and this helps us figure out what would be the possible rational roots of a polynomial equation. Kind of helps you kind of bring it back down to a very specific set of numbers that you know are going to be a possible answer for your problem. So instead of just, if you don't know anything about the problem, you don't know any zeros for it, and you can't factor it, instead of just trying to like guess and check numbers and see which one works, we can use this theorem to kind of help us hone in on specific numbers that we know. There's got to be one in this group that will work for us. So how do we find that? Well, we figure out two pieces from the equation, from your polynomial equation. The first thing is like what the constant is, and then what the leading coefficient is. I'm going to refer to those as P and Q for the two separate things. And so we put P over Q, which is what I have written right here. And what this means is that it's like this big equation right here that I'm highlighting right now. So P is going to stand for your constant, and that's going to be the plain number that's at the very end of your polynomial. So it's the number that has no letter attached to it. So it's just like a 10 or it's just an 8. The Q is going to be your leading coefficient number. So wherever the biggest exponent is for your variable. So if you've got x to the 5th, if that's the biggest one, you would want the number that sits in front of x to the 5th, whether it's a 1, a 2, a 3, or whatever they might put in front of it. And that goes on the bottom. And so how we set this up is we look for, what's my constant? So if my constant was like 5, I'd want to know what are the factors of 5? Well, 1 and 5 are the factors. And then I would look on the bottom, what are the factors of my constant? Or of my coefficient, my leading coefficient. So whatever number that is, you figure out what those factors are. Now, if we have bigger numbers, like 24, 36, and those kind of numbers, you're going to have more factors that you're dealing with here. Let's take a look at an example. We're just going to practice listing out the factors for now. We're not actually going to solve these yet. So they're going to give us something like this. X to the 3rd minus 3x squared minus 10x plus 24. Your P, like I said, is always the last number, the constant, so that's going to be the 24. And your Q is going to be what's in front of the term with the biggest exponent. So x to the 3rd is the largest exponent I see. What number is sitting in front of that x? 1. So 1 is going to be my Q. Okay, so P is 24. Q is 1. So what I'm going to do is, in my fraction here, I'm going to list out the factors of 24 on top, and then list out the factors of 1 on the bottom. So I would just kind of think about like going through, starting at 1 and going up to 2, 3, 4, and write down any of the numbers that you know that go into 24. So 1 is, of course, going to be a factor for everything, because 1 goes into everything. 2 can go into 24. So can 3. So can 4. 5 can't. I can't take 24 divided by 5 and get a whole number. So I'm going to skip over 5. So now if I kind of think about this, 4 times what number would get me to 24? 6. So I'm going to kind of think about like my pairings now. So 4 and 6 get paired. 3 and what number would get paired then? 8. 2 and 12, and 1 would go with 24. Okay, so those are my factors of 24. So you can kind of think about pairing them. And if it helps you, do like 1 and then put 24 at the end, and then do 2 and 12 until you kind of meet in the middle. What are the factors of 1? Just 1. Okay, so all of this is over a 1. So to simplify this, you're taking all of those numbers on the top divided by a 1, which is not going to change them. It's still just going to be 1, 2, 3, 4, 6, 8, 12, and 24. So I'm just going to write those out. Plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Now, all of those have a plus minus sign in front of them. So it's plus or minus 1, plus or minus 2, plus or minus 3, and so on. What this means is this list right here. There's some numbers in this list that I know would work for this polynomial expression for me. So if I didn't know anything about it, if I was given no information about what the zeros might be, I could come into this list and start testing these numbers to see if they're factors, to then help me find the remaining factors. So like I said, this is kind of, it helps you so that you're not just guessing and checking numbers. It gives you a specific list of numbers that there should be one in there that works, that you can then use to do what we were doing on Monday. Okay, so you guys go ahead and try number 2. Write out what your P and Q should be, and then write out your factors. So what's your P for this problem? What number's the P? Good. 5 is P. So Q is a what? A 2. Okay, what's the factors of 5? 1 and 5. What are the factors of 2? Okay, so from here, you have to take the top numbers and you have to put them over the bottom numbers. On that last one, it was all just over a 1, so it was everything divided by 1. So that's why they stayed the same, all those numbers on the top. For these ones, I would start by doing like 1 over 1, which is going to be 1. And then you could do 1 over the 2, which would be a half. So what are the other two factors then? What would be 5 over 1? 5, and then 5 over what other number? 2. And again, these are all plus minus, so it's positive, negative 1, positive, negative 1/2, positive, negative 5, positive, negative 5 over 2. So this is your list of factors that would work. Much smaller than the last one, okay? It really kind of cut that down, and that's just because of the numbers that we were working with. So what we're going to do next now is, after you have this list, we can test some of them in order for us to find a zero. So this is going back to what we started this section with, where they said, here's your polynomial equation and here's a zero. Here's one that works. What we have to do first is like find one that works. So from that list that we made, we're going to start testing those. Once we find one, then we can write out a new depressed polynomial, and we can use that to help us factor or use the quadratic formula or something else to help us find the remaining roots. All right, so we're going to start here. We have x to the third plus x squared minus 17x plus 15. Tell me, guys, what's going to be your p? Good. 15. What's going to be the q? 1. So let's start by making our possible list here. So factors of 15 would be 1, 3, 5, and 15. Factors of 1 are just going to be 1. So this is that situation that we saw on that first problem where I'm putting 1 over 1, 3 over 1, 5 over 1, 15 over 1. So it doesn't change any of those numbers. So my possible list is going to be positive, negative 1, 3, 5, and 15. So what I'm going to do is, using these numbers, I'm not going to do like a 2 or a 4. I'm going to use one of these numbers from my list here and try to see if I can get it to go in nicely to this polynomial. So this is going to be using that synthetic substitution process that we did on Monday. I'm just going to start with 1, positive 1. Okay, and I'm going to put that up in the box area. Grab my coefficients here now. So my coefficients for my equation up here. So I'm going to do 1, because that's in front of the x to the third. 1, because that's in front of x squared. A negative 17. And then a 15. I'm going to drop that first one. So remember, guys, what we're really wanting to have happen here is for my remainder to be a 0, because that told me that that number went in perfectly. So if I don't get a 0 here, that means that 1 is not a factor, and I'd have to go and test another number. Okay, so I'm going to do 1 times 1 to get another 1. Now I add that, so I get 2. 2 times 1 is 2. Add that to negative 17, I get negative 15. Negative 15 times 1 is going to be negative 15. So I got 0 for a remainder. That tells me that 1 is a good number. So I'm going to go ahead and just kind of circle it so that I know that worked. So now I'm going to take my 1, my 2, and my negative 15 and write a new polynomial. So remember, my problem up at the very top there started x to the third. So this new one has to start x squared. So it'd be 1x squared, or just x squared, plus 2x minus 15. Let's see if we can factor it. Can you guys think of two numbers that would multiply to a negative 15 but would add to a positive 2? So positive 5, negative 3. So x plus 5, x minus 3. And now I set those two pieces equal to 0 to solve for those other two zeros. So I'm going to get x equals negative 5 and x equals 3. And I found my 3 zeros, and I should have 3 of them because my leading term was an x to the third. So that 3 tells me that there should be 3 zeros out there. So putting them in order, I'm going to do negative 5, the 1, and then the 3. Now, if the 1 hadn't worked, okay, if I didn't get a 0 for my remainder, I would go and test another number. Kind of the worst part of these problems is if you don't get it right away, you have to go test another number, and if that one doesn't work, you have to go test another number until you find one that works. And unfortunately, there's really no like good way to do that. You just have to kind of guess one and check it and see if it works. I would suggest, you know, if like a positive one doesn't work, but maybe it was just a sign issue, maybe try the negative side. But it really is just kind of a guessing and checking process. There's really nothing that I can say that's going to all of a sudden make it a lot easier as far as like deciding what number to test first. Okay, so let's do another one here together. So let's start again by listing out our P's and our Q's. What number is in the P spot? Good, 20. And in the Q? 1. All right, what numbers go into 20? A 1 does, right? 1 and 20 would go together. 2 and what number? 10. 3 can't go into 20. Can 4 go into 20? Yep, 4 and 5. So there it kind of is your first pairing. So then the next number should be that 10 and then 20. So you should always be able to group numbers together. Okay, and then factors of 1 are just 1. So again, we're going to be just left with that plus minus 1, 2, 4, 5, 10, and 20. Okay, so let's go ahead and just try 1. Positive 1. What are my coefficients for this equation? Going back up to that original problem, what are my coefficients in that? Good. Now remember, I want a 0 to show up here for the remainder. So I'm going to bring down the 1. I'm going to do my process now. So 1 times 1 is 1, plus that negative 4 is negative 3. Times 1 is negative 3. Negative 2 plus negative 3 is going to give me a negative 5. Times 1 is just negative 5. 20 plus negative 5 is not 0. It's 15. So this doesn't work. So I'm going to go ahead and just, nope, cross it off. And I have to try another factor. Okay, so this is what I was talking about, that it may not always be 1. It might have to be another number. Okay, now because I've done these problems before, I know what factor works. Okay, so I'm going to go ahead and skip ahead. I'm not going to do negative 1 or positive 2. I'm going to skip to negative 2. I'm using the same coefficients as before, though. So 1, negative 4, negative 2, and 20. Okay, because I know negative 2 works here, I know I'm going to get a 0 for my coefficient, but I'm doing the same, or for my remainder. I'm doing the same process, though, as what I did before. Okay, so that one worked out for me. That means that negative 2 is good, so I'm going to go ahead and circle it so that I know that's one of my zeros. Now, if I write this as a depressed polynomial, again, I started with x to the third, so this is going to go down to x squared. 1x squared minus 6x plus 10. Are there two numbers that would multiply to 10 and add to a negative 6? Your factors would be 1 and 10 and 2 and 5. Is there any way to add those numbers to get to a negative 6? Nope. So this one's not factorable. So instead of factoring, we're going to use the quadratic formula for this one, which we did a little bit of on Monday. So just a quick reminder here, your A is a 1, your B is a -6, and your C is a 10. So we're going to go into the quadratic formula using these coefficients. So you always do opposite of B, so your B is -6, that's going to become +6. Plus or minus, under the square root sign, it's B squared. So -6 squared minus 4 AC, so times 1 times 10, all over 2 times 1. So I just need to simplify this to help me find the other two roots. Okay, so -6 squared is 36, and then we have minus 4 times 1 times 10, so that's going to be minus 40. Okay, so I'm going to stop here for a second. Notice underneath that square root, I have 36 minus 40. That's going to be a negative number. That means that eventually I'm going to have to square root a negative, so there's going to be an I that happens here. So my other two numbers, if I came back up and I looked at this list, -2 is the only one from this list that would have worked. So even if I kept testing other numbers like a 4, a 5, a 10, none of them would have worked. Only -2 did. So that's kind of what that tells us here. All right, so this is all over a 2. So we have 6 plus or minus. This is now the square root of -4 over 2. What's the square root of -4 going to become? Good, 2i. So 6 plus or minus 2i all over 2. Your whole numbers are 6, 2, and 2, so they can all be reduced by a 2. So 6 becomes a 3, and your 2's become 1's. So I'm just going to write this as 3 plus or minus an I. So those are going to be my zeros. -2, 3 plus or minus I. All right, so there are a couple more in here in the notes packets. We'll probably finish that up tomorrow. For now, though, I want you guys to kind of skip ahead.